In this lesson, we're going to review solving linear equations and also solving literal equations for a variable. In linear equations, that is, equations that have a variable that's not raised to an exponent, just multiplied and added and subtracted, we can solve for that variable by moving around the terms. So on the left side of the equation in example 1, we can do some simplifying first. 5k plus 2k is 7k plus 4. We've got some like terms to add, and then we've got unlike terms there as well. On the right side, we'll have to be careful about distributing that minus sign there. So k minus the quantity 3k minus 4 is k minus 3k plus 4, because we're actually subtracting a negative 4. Now let's combine the like terms together on the right side of the equation, and that gives us 1k minus 3k is negative 2k plus 4. Now let's move our variable terms, add 2k to both sides. 7k plus 2k is 9k. And if we add 2k on the right side, negative 2k plus 2k is 0, and we're just left with 4. Now subtracting 4 from both sides, 9k is equal to 0. And I want you to think about what 9k equals 0 is really asking you to do. Years ago, when you were in elementary school, you solved an equation like this, where it said 9 times blank equals 0. And you said, hey, that has to be a 0 that goes in the blank, so k must be 0. Now, I do want to add, we can take 9k equals 0, divide both sides by 9, and 0 divided by 9 is 0. But that's a little bit quicker for us to get to that if we just think about what it means. All right, in B, we have some fractional coefficients, and one of the things that you've learned there is we can clear the fractional coefficients by multiplying by the LCD, which is the least common denominator. And our LCD is equal to, the LCD least common denominator for 3, 2, and 4 is 12. So we're going to multiply both sides of this equation by 12. And then we need to distribute the multiplication. To do 12 times 2/3 really quickly in your head, because it will pay if you get really fluent with this, you want to think about what's 1/3 of 12 first. Well, 1/3 of 12 is 4, so 2/3 has to be double that, or 8. So 12 times 2/3 is 8. 12 times a half of 12 is 6. 12 times 2 is 24. And then here we have another fraction to multiply by. 1/4 of 12 is 3. So 5 times that, 5/4 would be 15 times d. All right, now I'm going to move my 8d over. So I'm going to subtract 8d from both sides. So 15d minus 8d is 7d. And now subtract 24 from both sides. And negative 6 minus 24 is negative 30. 24 minus 24 is 0. And so we just have negative 30 equals 7d. Divide both sides by 7, and we get d equals negative 37. We're going to get some fractions sometimes. Improper fractions, they're fine. Don't feel the need to change that to a mixed number. Next example has more fractions in it. Our LCD this time of 2 and 8 is 8. That's the smallest common denominator. So we'll multiply both sides by 8. And this one looks just a little bit different. So we're going to have to be careful about those multiple terms in the numerators of some of those fractions. So first, distributing to this first fraction, distributing our multiplication, 1/2 of 8 is 4. So we are left with 4 times the numerator, x plus 5. 8 times 1/2 is 4. And notice the use of parentheses there. That x plus 5 in the numerator has sort of a secret parentheses around it because we group numerators and denominators together if there are multiple terms in the numerator. So be careful with that. 8 times 2x is 16x. And then if we think about letting the denominator do the division, 8 divided by 8 for that second distribution here, 8 divided by 8 is 1, but we have minus 1 times the quantity x minus 3. Be real careful with that one, especially that one, because we have to distribute a 1, but we also have to distribute the negative as well. So on the left side, 4x plus 20, distributing the multiplication to the addition, plus bringing down the 4 equals 16x minus x plus 3. So let's clean up each side a little bit. 4x plus 24 equals 15x plus 3. Let's subtract off our 4x, and that'll give us 11x plus 3 on the left side, on the right side. Subtract the 3, that's 21 equals 11x. Now we've got to divide by 11, and x equals 21/11, another fun improper fraction. All right, we've got another variation here. This one has a multiplication outside of a parentheses. Again, we want to clear denominators, so you're going to multiply by the LCD, or at least common denominator. So 5 times 2/5 times x minus 2 equals 5 times x plus 4. Now, when we multiply things together, we have 5 times 2/5 times x minus 2 on the left side. You multiply 2 of them together, and 5 times 2/5 is 2, and then multiply the result times the rest. So 2x minus 4 equals 5x plus 20. Let's subtract off the 2x first, and then subtract off 20. Dividing by 3, x equals -8. It's a good habit to get into to box your final answers. All right, moving on. Some special types of equations. If an equation is always true for any value of the variable, we actually call this an identity, and there are an infinite number of solutions. We also say all real numbers are solutions, but if you want to, you can use the symbol for all real numbers. I'm going to tend to stay away from symbols because sometimes we forget what they mean, so I'm just going to write out the words all real numbers all the time. Now, if an equation is never true for any value of the variable, it has no solution. And that can be abbreviated using this symbol, which is the empty set. So that indicates a solution set that has no numbers in it. That is to say, there is no solution. Now, quick tip. When you're solving linear equations, it's easier to add or subtract variable terms before adding or subtracting constants. Constants don't have variables in the term. And I'll show you why in a moment. So we're going to solve each of these equations and indicate if it has no solution, an infinite number of solutions, or if it actually has a solution. So we need to do a little cleaning up here. 2g minus 4 equals 2g minus 6. 2g minus 8 on the left side equals 2g minus 6. Now you'll notice that there's a 2g on both sides. When we subtract our variable terms, you get -8 equals -6. This statement is never true, so that means that there is no solution. Be really careful when we're asked to solve. The answer here is no solution. Don't circle -8 equals -6, because that itself is not the solution. What's important for you to understand is that when we solve an equation, we're writing a series of equivalent equations. Each one of the equations that I wrote below the one before has the same number as its solution. And since the equivalent equation that we wrote on the last line is very clearly never true, then the equation and all the equations above have no solution. All right, let's check out B. We're going to distribute our multiplication to the addition on the left side, and the same on the right side, being careful to distribute that negative. Negative 2 times negative 2a is positive 4a. Let's clean up each side by adding together like terms, and now you're going to notice that I made a mistake here. Let's fix my mistake. That I should have distributed there 4a plus 8, distributed instead of the 4a plus 2, because I forgot to distribute to that second term initially. All right, so we have 4a plus 8 equals 8 plus 4a. You'll notice this one looks very similar to the last one. We can subtract off 4a from both sides. If we do that, we get 8 equals 8, which is always true, no matter what the value of the variable is. So this one has a solution of all real numbers. I can actually replace a with any value that I want to, and it will make the equation into a true statement. Last one here. Let's distribute our multiplication to the addition. That's 6d plus 3 equals 4d plus 3. And I want to move my variable term first. So 6d minus 4d is 2d. 2d plus 3 is equal to, if we subtract 4d off the right side, we get 3. Now let's subtract 3 from both sides, and that'll give us 2d equals 0. So 2 times what equals 0? And the solution is 0. We want to be careful here. If you actually, I'll go from our second step there, 6d plus 3 equals 4d plus 3. And if you do this and you subtract 3 off from both sides first, you'll get 6d equals 4d. Now it's possible to solve that, but this kind of looks like a no solution type of a situation, but it's not. It's actually d equals 0 is the solution to the equation, because 6 times 0 does equal 4 times 0. But if you don't subtract the variable term first, you might get a mistaken impression of the solution to this equation. All right, let's check out these examples where we're solving what are called literal equations. Literal equations are just formulas or equations that have more than one variable in them. Before we try to solve this first one for the variable, we might want to just clear those fractions. So let's multiply both sides by 4. So 4 times 1/4 ab squared minus x equals 4 times c. And when we distribute to the first term, 4 times 1/4 is 1, and 1 times ab squared is just ab squared. In simplest form, it doesn't need that 1 coefficient. Now distributing to the second term, 4 times x is 4x, and that's equal to 4c. I want you to think for a moment about what would happen if the letters other than a in this, which is the one that we're solving for, in this equation were replaced by numbers, because I want you to really think of them as if they were numbers. So I'm just going to make up some values. So for instance, let b equal 5, and let x equal 3, and let c equal 2. If that's true, if b is 5, then a times b squared would be a times 5 squared, which is 25a. If x were 3, then 4x is 12. And if c were 2, then 4c is 8. Now I want you to think about what we would do to solve this. We're not actually just going to solve it, but we would add 12 first, and then divide by 25a, or not 25a, but just 25. Okay, so when we solve the equation here, we're going to add 12, but 12 was that 4x. So we're going to add 4x to both sides. that gives us ab squared is equal to 4x plus 4c, or you could write it 4c plus 4x, it doesn't matter. And then divide by 25. Now 25 was the b squared, so we're going to divide by b squared. And that gives us a is equal to 4x plus 4c divided by b squared. That's solving for a in terms of the other variables. Okay, I'm going to get rid of everything here that we did because we need that space to do the next example. All right, next one has a fraction. So again, let's start by clearing fractions. So 5 times 3/5 times a plus 2 equals 5 times k. We multiplied by 5 on both sides. You can grab your handy-dandy cancellation pen. Times 5 and divided by 5 undo one another, and we're just left with times 3. 3 times a plus 2 is 3a plus 6 equals 5k. If we're solving for a, you have to undo the plus 6 first. So 3a equals 5k minus 6, and then divided by 3. A equals 5k minus 6 divided by 3. It is important that you recognize that you cannot cancel your 6 and your 3 there. That does not reduce since the other term in the numerator does not have a factor of 3 in it. In C, we need to, again, clear fractions. We have that different kind of fraction. So we're going to multiply 4 times a plus 5 over 4 equals 4 times c plus 2b. 4's cancel because multiplication undoes the division, and that just leaves us with a plus 5 equals 4c plus 8b. We only have one thing to do to isolate a, or to get a by itself, and that is subtract off the subtract off the 5 from both sides. So there's our equation solved for a. And now we have another one where we're also solving for a. However, I want you to notice that there are two terms in this one that have the variable a in them. So we'll need to combine those terms or move them to the same side. I'm going to add 7a to both sides. That'll give us 9a minus 3b plus c equals d. And if we added 7a to the right side, that gets rid of the minus 7a. Now we also have 3b that's being subtracted from 9a, so we'll need to add that to both sides. C was being added to 9a, so we'll subtract that from both sides, and then the d was already positive on the right side. And last step would be divide by 9. So a is equal to 3b minus c plus d divided by 9. And the last example here is very similar to the one before. You'll notice we have a terms, so we're going to do a similar technique here. I'm just going to recopy it over on the right side here. And so we'll add AC to both sides. But notice those are unlike terms, so that means that we cannot combine the 2a plus AC. And then, very similarly to what we did before, we're going to add 3b and subtract c from both sides. And then here's the trick. How do we get a by itself? The trick is we are going to undistribute the a. So undistribute. A was distributed to what? And that what would be 2 plus c. So we're just re-expressing the left side using the distributive property, but sort of backwards from how we're used to using it. And then think about what that 2 plus c is doing to a. It's multiplying. So in order to undo it, we need to divide both sides by 2 plus c. And that leaves us with a equals 3b minus c plus d divided by 2 plus c. It's important to realize that you cannot just add 3b and subtract c from both sides. If you did that, what you would have instead, and I'm just going to write this below here and illustrate this for you. Here's our original equation. And if we just add 3b and subtract c, that would be what we would get. However, oh, I'm sorry, we're not even finished there. Get rid of that box. There we go. We would still need to divide by 2. And if we divide by 2, you'll get something that looks like this. But it's important to realize that that answer is not really solved for a, because it says a equals, but then you'll notice on the other side of the equal sign there is an a over there. So you're describing a using the letter a. When we solve an equation, it has to be solved for a in terms of just the other variables. This is very much like the idea of you can't use a word in its own definition. So similarly, when you solve for a variable, the other side of the equation should be just the other variables and numbers and operations. All right, that's it for the lesson.